I'm pretty new to this blogging ordeal. I've been watching YouTube videos for years, listening to other people's blogs, listening to their stories, and I think it's about time I start making my own. Well, I've tried before, but I've always had terrible cameras, video quality, mic qualities. I mean, you can listen to my older videos and you'll see what I mean. Let's talk about biology, since that is my field of study. It's a huge field. I mean, you could talk about conservation, molecular cellular, zoology, botany, ornithology, mycology, and much, much more. I study molecular, cellular, and developmental biology. It's an amazing field. Today, I got to teach middle school teachers how to tell the difference in sex of the Drosophila melanogaster, which is a model organism known also as the fruit fly. I don't just want to bore you with biology. I can keep you up with what I'm doing in life. Me, I quit Starbucks a few months ago, which I worked at for 5 years, and for the first time, and living life unemployed. Living off of financial aid, which is amazing, which I feel like I do deserve. I mean, I did serve 4 years in the military beforehand, and now I feel like the contribution I made for society has given back with financial aid to get me through college. When I'm done with this, I'm planning on going for my PhD in theoretical biology or computational biology. I want to study how these cells create what we call gradients of molecules. We know in neurons that there are thresholds of certain molecules, especially sodium and potassium, in which it reaches this threshold and it sends off a synapse. I believe that these gradients are important in other processes. We've also known that in development, we call it the maternal polarization. We see in the Drosophila before the egg is even fertilized, it becomes activated, and we have the caudal and rostral sides of the eggs are already determined by a setup or gradient of molecules. A lot of our cells are developed by other pathways and gradients, specifically sonic hedgehog, Wnt, BMPs, and much more play a major role in development. And they all create gradients which interact with one another. What I want to do with these, or learn how to calculate and develop theoretical equations, which we can take a sample out of a cell and be able to tell exactly how it's going to develop. And when you get older, we can look at your genetic makeup and tell you, oh, wow, you are genetically inheritable of these diseases, or you're genetically prone to these diseases. But what we know now in human diseases, you may be prone to a disease, but it doesn't mean you're going to get it. We want to find out what kind of environmental triggers will happen to it. There's these copy number variances which can affect you and have you highly prone to diseases like schizophrenia, mental retardation, or even learning disabilities, cognitive issues, etc., etc. We're finding out that a lot of people who do suffer from these diseases share the same types of mutations or copy number variances as in these cases. The fun life of being a student is you don't have a life. Well, I should type up an essay, do some math, and hope I get some sleep tonight. Mwah.